Okay, welcome to metric conversions. Yesterday, we were talking a lot about the metric system, and I asked you to start to memorize how many milliliters were in a liter, or how many kilometers are in a meter, or vice versa. That's really going to come into play here because we're going to start to jump from meters to kilometers or milligrams to grams. And we're going to use proportions to help us get there. So as always, you can pause the video whenever you need to catch up on the notes, or if you want to hear something again, feel free to rewind it. Really use this video to your advantage. So we're going to start right out with the practice problem. I'm going to ask you to convert 5 grams into milligrams. Okay, so we have something that weighs 5 grams, and we want to convert that into milligrams. So how many milligrams are in 5 grams is another way to think about it. The first thing we're going to do is give ourselves a key, and we're going to start to set up our proportion. Before we jump into the specifics of the problem, we're going to ask ourselves, hey, how many milligrams are in a gram? And this is what I wanted you guys to start to look at yesterday, earlier in the week. And we are going to start out with a ratio that tells us how many milligrams are in 1 gram. And that ratio is 1,000 milligrams are in 1 gram. This is our key ratio that we're going to use to help solve this problem. We're going to eventually set up a proportion, but we're always going to start off with the key that shows us, in general, how many milligrams are in 1 gram. And we know that there's 1,000 milligrams for every 1 gram. Okay, so we've got our key. Now, let's go back to the problem and fill in the information that we know. We're going to make another ratio on the right side here. That's going to be milligrams to grams. So 5 grams. Am I going to put that up here, or am I going to put it down here? Well, I'm going to make sure that it's in the denominator because I need it to match up with my units. Okay, just like all these proportion problems, we are lining up our units. So I'm not going to put 5 grams up here because that doesn't line up with milligrams. I'm going to put it in the denominator so that it matches up with this denominator. So I'm filling in the information on the right side of my proportion. Okay, so I got 5 grams. How about milligrams? Where's that going to go? And do we know how many milligrams? No, we don't. So that's going to be X milligrams. And we have set up our proportion. Notice that our units are lined up. The left side is what's given, or really what's standard. We know that there's 1,000 milligrams in every 1 gram, so we're going to write that ratio first. And then we're going to fill in the right side of our proportion with what's given in the problem. And now we just solve, just like we would any other proportion problem. How do we solve proportions? Well, first we try to make it easy on ourselves and we see if there's a relationship. And in this case there is. How can I jump from 1 to 5? Well, since my number is getting bigger, I know that I'm going to multiply. What am I going to multiply? Well, we know 1 times 5 is 5. So there's my relationship right there. I'm going to apply it up here, times 5. Now I just need to work this out. 1,000 times 5. Now there's 2 ways to go about this, and that's what these metric conversions are all about, is using a trick. And I'm going to show you that right here. So if I do 1,000, this isn't the trick, this is the traditional way, I'm going to get 5,000. So there's our answer. It's 5,000 milligrams. So there are 5,000 milligrams and 5 grams. Those two are equivalent. So there's my answer. a trick I can use when I'm multiplying by a denomination of 0. That means either 10, 100, 1,000, 10,000, and so on. All I need to do is add these zeros, in this case 1, 2, 3, to the back of this 5. What do I mean? Well, I'm going to start with 5, and I'm going to add 1, 2, 3 zeros, because there's 1, 2, 3 zeros and 1,000. So that's a trick I can use when I'm multiplying by a denomination of 10 or 0. Just in the same way that 5 times 10 is 50, we're going to use that same trick to get bigger numbers here. So either way, we're going to get there to 5,000 milligrams. So that's our first conversion. Let's do one that's a little harder. Let's convert 12 meters to kilometers. Okay, we're going to start the same way. We're going to make ourselves a key. We have to ask ourselves, hey, how many meters are in a kilometer? And you can always look back to the notes that we took yesterday to figure out what that ratio is, because that's what we're going to start with. It doesn't matter what's on top or what's on bottom. I'm just going to say, in terms of units, we know that there are 1,000 meters for every 1 kilometer. And again, this is our key. We know this from yesterday's lesson, that in 1 kilometer there are 1,000 meters. After we've created our key, based off our notes from yesterday, we are going to fill in the information here, making sure that our units are lined up. So 12 meters, that's going to go in my numerator, because I've got meters in my numerator. And I'm trying to figure out how many kilometers, so I don't know that number yet, so I'm going to leave that as X kilometers. And there's my proportion. To solve this proportion, we look to see if there's a relationship. Is there a relationship between 1,000 and 12? No, those aren't very nice numbers. So we're not going to be able to multiply or divide in this case. We're going to have to do it algebraically, which is really good practice for you guys. So I'm going to rewrite this proportion without any units to make it easier on myself. So I've got 1,000 over 1 equals 12 over x. Now when we're trying to solve proportions algebraically, we need to get our variable out of the denominator. In order to do that, we're going to find the reciprocal. And if we do the reciprocal on the right side, we've got to do it on the left side. So I'm going to flip these fractions around, and it's going to turn into 1 over 1,000 equals x over 12. Notice my numerator became my denominator, and my denominator became my numerator on both sides. Cool. So now we're trying to isolate just trying to get my paper. Here we go. I'm trying to isolate this x. Right now it's being divided by 12, so I need to multiply by 12. Multiply by 12 on the right side, multiply by 12 on the left side. My 12s are going to drop out, leaving me with x. And over here, I can't cross-reduce anything. I could, but I want to keep that 1,000 in there, and I'm going to show you why in a second. So this is going to turn into my like a multiplying fractions problem, where I'm going to multiply across. 12 times 1 is 12. 1 times 1,000 is 1,000. Okay, so what I'm left with is a division problem. What's 12 divided by 1,000? Now I could do it this way. And see how many times 1,000 goes into 12. This is going to be hard because I need to add a decimal point, add some zeros, and figure it out that way. But a trick for dividing by a denomination of 10 is very similar to what we've done before, but the decimal is going to go in the opposite direction. Up here, my decimal was 5, or really 5 with the decimal here, and I moved the decimal place over 3 times based off 1, 2, 3 zeros up here. I'm going to do that same thing, but the opposite when I'm dividing by a denomination of 10. So look what I'm going to do. Here's my 12. Here's my decimal point. It's not going to move to the right because my number is going to get smaller. It's going to move to the left. And how many times am I going to move the decimal place over? Well, I've got 1, 2, 3 zeros. And I'm going to add a placeholder here because I know I'm going to need it. So I'm going to move it over 1 time, 2 times, 3 times. And there is my answer. So my decimal place moved over 3 times to the left because I had three zeros over here. So my final answer is 0.012. And what was I looking for? I was looking for kilometers. There's my answer. Now, I'm going to cut this video off because I've been talking here for a while. What we're doing here is we're setting up our proportion, using our metric conversions, and then we're also using the trick of dividing by a denomination of 10 and multiplying by a denomination of 10. That's what we're going to do in this lesson here. See ya.